Now that we've talked about and laid all the groundwork, we've done all the vocabulary, we've talked about all the individual pieces, we can bring it together and talk about how all these pieces interact and kind of the math that goes behind them. So in kinematics, we haven't introduced this word. I've probably used it without realizing it a couple times, but kinematics is the study of motion. So if we're looking at things moving, that's kinematics. And so everything we've been talking about is kinematics. It's just the big word to describe this unit. Let's create a table to kind of talk about the different terms, and you'll be able to see kind of how they relate. So we've got the name of the quantity, we've got the type of quantity that it is, we've got the variable, and then we'll have the unit. So we'll start with position. We'll represent, well, let's see if you can do this on your own. I'll write them all out. Position, time, velocity, acceleration. I would encourage you to try and kind of go through and fill these out. Type means scalar or vector. Variable means what the variable is. Unit is, what type of units the measurement uses. I'd encourage you to pause here, give it a shot for yourself, see what you can remember, and then check in after you've given that a shot. Okay, position is a scalar. Time is also a scalar. Velocity is a vector. Acceleration is a vector. Position is represented with the variable x, time with the lowercase t, vector with the lowercase v, acceleration with lowercase a, all lowercase. Units, position is typically measured in meters. Time in seconds, velocity in meters per second, acceleration in meters per second squared. So this kind of gives you an idea. You can kind of see how they're similar, how they're different, stuff like that. Now, we're going to talk about combining kinematics equations. We introduced earlier where you saw that delta x over delta t equals v bar. You also saw where delta v over delta t equals a bar. And we're going to assume in this class constant acceleration. So for constant a, we can assume that v bar is also equal to the initial velocity plus the final velocity divided by 2, like your standard average. This only works for this assumption that we're doing with constant acceleration, but if we weren't, we'd have to do calculus, and that's not something that is in the scope of this course. Now, taking those three equations that we have up there, we can do all sorts of rearrangements and combining and interacting with things, and that ends up giving us 4 key kinematics equations that we're going to use. And these are the main ones we use going forward. The first one we use because it deals with 3 of the quantities and not acceleration. And this is x equals x naught plus v bar delta t. So this is useful because if we know positions, we know velocities, we know time, we can figure out, and one of those is missing, we can figure it out. We don't need to know the acceleration. There's also one without an x. The final velocity equals the initial velocity plus the average acceleration times change in time. These two you can kind of just see are rearrangements of the 2 average velocity average acceleration equations. Now if we do some math that I'm not going to do here, but if you're curious, you can ask me and I'll show you the derivation in class. We can find an equation that doesn't have a final velocity. Plus 1/2 a bar delta t squared. So if we know some position information, the initial velocity times acceleration, one of those is missing. we can solve for this. So you'll notice it doesn't have the final velocity. We don't need to know the final velocity for this equation. Just like in the first equation, we didn't need to know the final acceleration. In the second equation, we didn't need to know the final position. And then finally, we don't need to know the time. We can use the relationship that the final velocity squared equals the initial velocity squared plus 2 times the average acceleration times the change in position. So these are our 4 kind of main kinematics equations. They'll be useful to familiarize yourself with, to play with. They'll be doing most of what we end up calculating will be based off of these. Yeah, so that's what we're going to work with kind of most of this, the rest of this unit.